This is Mrs. Zappia with Lesson 16, the computation of the slope of a non-vertical line. Student outcomes for this lesson. Students use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. Students use the slope formula to compute the slope of a non-vertical line. Pause the video and copy the essential question. In words, how do you find the slope of a non-vertical line? Using what you learned in the last session, determine the slope of the line with the following graph. Pause the video and complete example 1 and 2. Resume the video when you are ready to check your work. In example 1, we have a rise of 3 and a run of 1. Giving us a slope of 3. In example 2, we have a rise of 2, a run of 1, and a slope of 2. Example 3. What is different about this line compared to the last two examples in terms of slope? Pause the video and determine what is different. The horizontal difference is not equal to 1. Again, the run is not equal to 1, as it was in the previous two problems. Based on what we learned in the last lesson, what do we know about the unit rate of a problem and the slope? In the last lesson, we found the number that described the slope or the rate of change of a line. In each instance, we were looking at a special case of slope because the horizontal distance between the 2 points used to determine the slope, P and Q. Let's label those. Here we had P, here we have Q, was always 1. Since this horizontal distance was 1, the difference between the y coordinates of points Q and R, and this is point R, is equal to the slope or the rate of change. For example, in this graph, we have the distance PQ of 1. Actually, let's do this without any numbers. We know that the unit rate is equal to the slope. And the slope or the rate of change of the line M is equal to the run, which is the distance of PQ, and the rise, which is the distance of QR. And this is what we learned based on the last lesson. Now, our task is to determine the rate of change of a non-vertical line when the distance between P and Q is a number other than 1, as it is in this first problem right up here. Are there points on the line with integer coordinates that we could use to help us determine the slope of this line? Let's take a closer look at the example. There are several points on the line with integer coordinates that we could use. Recall that we want to select points with integer coordinates because our calculation of slope will be simpler. In each instance, from one point to the next, we have a horizontal distance of 1 unit, noted by the red segment. And the difference in the y values between the 2 points, which is a distance of 2, noted by the blue segments. When we compare the change in the y values to the change in the x values, we have a ratio of 2 to 1, which is equal to the slope. Each of the slope triangles have a ratio of 2 to 1. Here we have three different triangles, and they all have the ratio of 2 to 1. Using the same line, let's take a look at a different pair of slope triangles. What is the ratio of this larger slope triangle? The ratio, the run, is 2 and the rise is 4. So first here we have what is the ratio of one of the slope triangles, and we had a slope of 2 over 1. And we have a different slope triangle, and now we have a ratio of 4 over 2. What do you notice about the ratio of the smaller slope triangle and the ratio of the larger slope triangle? I notice that the ratios are equivalent. I know that 2 over 1 is equivalent to 4 over 2, and they are both equal to 2. We have worked with triangles before where the ratios of corresponding sides are equal. We call them similar triangles. Are the slope triangles in this diagram similar? And how do you know? They are similar. We know this because of the angle-angle criterion. Each triangle has a right angle at the intersection of the blue and the red segments, and both triangles have a common angle. The common angle that they have is this green one. That's the green angle in the small triangle and the green angle in the large triangle. And they both have a 90-degree angle. So by angle-angle criterion, these two triangles, the small one and the large one, are proven to be similar. When we have similar triangles, we know that the ratios of the corresponding side lengths must be equal. That is the reason that both of the slope triangles result in the same number for slope. Notice that we still have the correct number for slope of the line, even though the points chosen did not have a horizontal distance of 1. Now we can find the slope of a given line of any 2 points on a line. The horizontal distance between the points does not have to be 1. Let's look again at example 3. What do you think the slope of this line is? Well, let's take a look at the run. Here is our horizontal distance and our vertical distance. And this gives us 2 over 3. We also have a horizontal distance and a vertical distance that forms another triangle. In this triangle, the vertical distance is 4 and the horizontal distance is 6. We know that these are similar triangles because of the angle-angle criterion. They both have a 90-degree angle and they both have this common angle, so they are similar triangles. That means that their side lengths will be in proportion and will have the same ratio. We can also have a third triangle with these points. This gives us a vertical distance of 6 and a horizontal distance of 9. All of these have a slope of 2/3. So this goes back to the essential question, or rather the goals for our lesson, and that fulfills this first objective. Students use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line. So we have answered the first part of our lesson. Exercise 1. Select any 2 points on the line, label as P and R. Identify the coordinates of point P and R. Find the slope of the line using as many different points as you can. Identify the points and show your work to the right. Here is one example of P, Q, and R, and this shows that our slope is 8/4. Here is another example. Perhaps you put your points here, P, Q, and R, and then your slope is 6/3. If that was not your answer, perhaps you used this one, P, Q, and R, and this gives you a slope of 4/2. Or perhaps you use this one. Let's group that all together. In which case your slope would be 2/1. All of these are equivalent ratios with different P, Q, and R's. We have shown that you can have distinctly different points on the same line and come up with the same slope. And in this case, all of them showed the slope of the line to be 2. Can the slope of the line be found on any 2 points? So just remember, when we're talking about the slope of the line, we are talking about the slope of this non-vertical line. Let's go ahead and label our points so that we can see them a little bit better. Down here we have point P, and point P is made up of the coordinates P⁻1, P⁻2. This is point Q. Point Q is made of the coordinates Q⁻1, Q⁻2. And this is point R. Point R is the coordinates R⁻1, R⁻2. Now we know the slope of the line L. Okay, so M stands for the slope. We want the slope of line L. It is equal to the distance of QR, and that's the difference, the distance of QR. Now remember, that is the vertical distance, over the horizontal distance, which is the distance between P and Q. The distance between P and Q. So that is how to find the slope of this line. From the last lesson, we found the length of the segment QR by looking at the y-coordinate. Okay, so the segment QR, that would be this segment that is blue. By looking at the y-coordinate. Without having to translate, we can find the length of segment QR by finding the difference between the y-coordinates of the points. The difference of the y-coordinates of the points. The difference of the y-coordinates of the points. Similarly, we can find the length of segment PQ. Segment PQ will be the red distance. And we find the distance of PQ by finding the difference of the x coordinates. Let's use a different highlighter for that. This will be the difference of the x coordinates. So this will be the distance of q sub 2 minus q sub r, or rather r sub 2. Okay, that's right here and right here. And then the denominator is the difference in the x coordinates, which will be p sub 1 minus q sub 1. Let's look at an example with coordinates rather than variables. First, let's label our diagram a little bit better. So we have point P, and that is going to be the coordinates 1, 2. We have point Q with the coordinates 6, 2. And we have point R with the coordinates 6, 4. What do you notice about the y coordinates of P and Q? The y coordinates of P and Q, 2 and 2. Notice that they are the same. What do you notice about the x coordinates R and Q? The x coordinates of R and Q, they're the same. They're both 6. By substitution, we can show the slope formula. Before we write the formula, let's write the q's and r's by the coordinates. By point P, this is P sub 1 and 2 is P sub 2. The x-coordinate is P1, the y-coordinate is P2. For Q, the x-coordinate is Q1, and let's do that with a small q, a lowercase q. And the y-coordinate is Q sub 2. And for the point R, we have R sub 1 is the x-coordinate and R sub 2 is the y-coordinate. So notice that the sub 1 is always the x-coordinate and sub 2 is always the y-coordinate. Now we also notice that Q2 and P2 are equivalent to each other, and therefore they can be substituted. So by our substitution, we have the slope is equal to the distance between QR, that's our rise, over the distance of PQ, that's our run. To find the rise, we know that we can subtract Q2 minus R2. Okay, and Q2 minus R2, that would be right here, 4 and 2. And then the run would be subtracting P1 minus Q1. And that will equal P sub 2 minus R sub 2 for the vertical change over P sub 1 minus R sub 1, which is the horizontal change. Translate the slope formula into words. It's the difference in the y-coordinates over the difference in the x-coordinates. Let's look at that one more time. It's the difference in the y-coordinates. This is the difference in the y-coordinates. Here is your y-coordinate. Here is your y-coordinate. So we have, using these numbers, 2 minus 4. And then the run is the difference in the x-coordinates. P sub 1 minus r sub 1. So then we have P sub 1 minus r sub 1. 1 minus 6. So we have negative 2 over negative 5, which will give us 2 over 5 for our slope. This has a difference of 5. That's our horizontal change. And then our vertical change is a difference of 2. So our slope is 2 over 5. Suppose we are given a horizontal line. So see where the P and the R are. Based on our work in the last lesson, what do we expect the slope of this line to be? The slope should be 0, because if we go 1 unit to the right of P, then identify the vertical difference between that point and R, there is no difference. Therefore, the slope is 0. Determine the slope of a line using the slope formula. Okay, so our slope formula, again, let's write it down. M is equal to P sub 2 minus R sub 2. That's going to give us our vertical difference, the difference in the y values. And the run is the difference in the horizontal values, P sub 1 minus R sub 1. Remember, those are the x values. So the vertical change is 0, and the horizontal change is P over, or rather, P sub 1 minus R sub 1. And we don't know the numbers. And 0 divided by anything is 0. So the slope of this horizontal line is 0. Now, for the general case, we want to show that we can choose any 2 points, P and R, to find the slope, not just a point like R prime, where we have fixed the horizontal distance at 1. We know that triangle PQ prime R prime, that's the small triangle, is similar to triangle PQR, which is the large triangle. Then the ratio of the corresponding sides will be equal, and the ratios are equal to the slope of the line L. Are triangle PQ prime R prime and triangle PQR similar? Explain. Well, we know that those two triangles are similar. They both have a common angle. The common angle is in green, and they both have a right angle. So our first triangle, let's do this. Our first triangle, we have this angle in common and the right angle. And then the second triangle, okay, so they both have a right angle and they both have that P angle. So yes, they are similar, and that way we know that they will have the same ratio and the same slope. Now what we want to do is find a way to express this information in a formula. Because we have similar triangles, we know the following. You may not necessarily need to write this part down, but just follow along. We know that r prime q, okay, the distance of r prime q prime over the distance of r q. Do you remember this from the last module? We know that that will be equal to the distance between p and q prime divided by the distance of pq. And we know that that also will have the same scale factor or rate of change as pr prime over pr. Hopefully you remember that from the last module. This is r, the scale factor or the rate of change. Based on our previous knowledge, we know that the distance r prime q prime, take a minute and find that, r prime q prime is equal to m. Okay, that is the slope. Why? Because this distance is 1. And we know that pq prime is equal to 1. And that's right here, pq prime equals 1. Then by substitution we have this. M, which is the slope, over rq is equal to 1 over pq. This is equivalent to m over 1 equals the distance between rq over pq. M over 1 simplifies to m, and this gives us the distance of rq over the distance of pq. We also know from our earlier work that the length of rq is equal to p sub 2 minus r sub 2. Those are the y values. And we know that the length of pq is equal to p sub 1 minus r sub 1. Those are the x values. So by substitution, our slope formula, drum roll please, is p sub 2 minus r sub 2, which is the change in the y values, over p sub 1 minus r sub 1, which is the change in the x values. Now we have a formula for the slope of the line that can be used for any 2 points. In this lesson you have learned the slope of a line can be calculated using any 2 points on the same line because the slope triangles formed are similar and corresponding sides will be equal in ratio. On a given non-vertical line, let any 2 points, P and R, be chosen, with the coordinates P1, P2, and R1 and R2. Then the slope of the line is written as follows. The numerator is P sub 2 minus R sub 2, and that represents the vertical change, the rise, and that is the change in the y values, while the numerator is represented as P sub 1 minus R sub 1, and that represents the horizontal change, or the run, and that is the change in the x values.